Let's do another example. What is the voltage of a cell that is H2 gas, copper 2+ ions, making 2 hydrogen ions in solution, and copper metal. This is very similar to the last example that we did. What is the voltage of this cell? Whenever you're being asked to calculate the voltage of a cell, you're being asked to do an E-cell calculation, and that is going to be the cathode minus the anode. So you have to figure out the voltage of the cathode as well as the voltage of the anode. And we're going to write the half reactions, but I'm going to show you an even faster way to go about doing this. So we know a couple of things. Well, really, we know more than a couple things, but in terms of this, we know one really important thing. And that important thing that we know is that the voltage that we calculate, E-cell, must be positive. Now, I can remember when I was in Gen Chem, I don't remember a lot about being in Gen Chem because it was a really, really long time ago, but I do remember this concept that the voltage must be positive really, really confused me. I didn't understand why the voltage needed to be positive in these reactions. I thought, okay, so if we're setting this reaction up and the electrons are moving in this direction from left to right, which is how we always draw it, why does the voltage always have to be positive? I mean, if I set cell A up and cell B up and I move the electrons from A to B and I get a positive voltage, that's all great. Why couldn't I just flip those cells around? Put B over here, put A over here, and if I make the electrons go this way, wouldn't that be a negative voltage if I turn it around? That just really blew my mind. So, finally, somebody explained it to me. If A and B, A on the left and B on the right, the electrons go this way and you get positive voltage, if you come along and say, oh, I'm going to trick you, I'm going to put B on the left and I'm going to put A on the right, the electrons say, no problem, we're just going to go this way. And you're still going to get a positive voltage. So the electrons don't know left to right or right to left. The electrons just know which way to go in order to produce positive voltage. That is why voltage always ends up being positive. It doesn't matter what you might call the cathode or what you might call the anode. You can call it whatever you want to call it. The electrons are always going to proceed in the same direction. So we know that the voltage has to be positive. We also know that we have these 2 half reactions. And one half reaction involves hydrogen gas and H+ ions. So I'm not even going to write this as a half reaction anymore. I'm just writing the 2 components of this half reaction. And our other half reaction is copper 2+ and copper. Copper 2+ and copper. So what I'm going to do now is I'm going to go back to those data tables, alphabetical order, and I'm going to look for a half reaction that has H2 and H+, and I'm also going to look for a reaction that has Cu2+ and Cu. And I don't care, left, right, left, doesn't matter. I'm just looking for those components. So we're going back to the data table and get rid of all this stuff that I did. Here we're looking for copper and copper 2+. Copper and copper 2+, and we're already right at the coppers. Copper and copper 2+, and I'm not caring about what order it's in terms of what's on the left and what's on the right, 0.3419 volts. And I'm going to write that down here. 0.3419 volts. Now I'm looking for hydrogen and H+. Hydrogen and H+, H2 and H+, which is our 0 volt. That's our standard cell. So this one is 0. Now, in the previous example, I said what you have to do is figure out what's the oxidation, what's the reduction, so that you can plug them into this reaction correctly. And it's going to be pretty hard for us to figure out the oxidation versus reduction, because the way I have written these half reactions, we're not seeing any electrons at all. So oil rig is not going to help us here, because we can't see electrons being lost or gained. We could probably think about it, but I don't really want to think about it. What we know is that the voltage must be positive. We have two options here for E cell. We have two different ways that we can do this calculation. We can go 0 minus 0.3419, or we can go 0.3419 minus 0. One of these is the cathode and the other one is the anode, and these are the two possibilities that we can come up with. Only one of these is going to be a positive number every single time. For every single one of these problems that you solve, one will give you a negative one number and the other one will give you a positive number 100% of the time. We can see that the first way that I wrote it is giving us a negative voltage, which means that that is not correct, because the voltage must be positive. The electrons do not care what you think is the cathode. The electrons are always going to move in the right direction, in the correct direction. So the positive voltage is the correct answer, the correct potential or voltage for this cell. The answer is 0.3419. This is also really helpful in identifying, it's another way of identifying what's the cathode and what's the anode, because we know that this is the correct way to calculate E cell because it gives us a positive number, and we know that E cell comes from cat minus an. We also now know that the cathode is the half reaction that has the 0.3419 voltage, and the anode is the half reaction that has the 0 voltage. So we can figure that out because we plugged things in correctly. We know that this is the cathode, and we know that this is the anode, because that's the only way that we're going to end up getting a positive number.